Communication question 4 on polynomial functions. List all the possible number of turning points that a degree 7 polynomial function can have. Okay. Now it's a knowledge based plus communication question. So you need to describe how you get your result. Okay. Most of you know the result, but the idea is to explain how. Okay. List all possible. Remember, all is the key word here. All possible number of turning points that a 7-degree polynomial function can have. Right? Now, let's look at 7 is odd degree polynomial. Let's try to sketch some scenarios here. So first one, 7 degree could be like this, right? It could just go flattened out like x cubed, or more flattened. It's like a function. I could write this as x to the power of 7. Do you see that? X to the power of 7. When I write x to the power of 7, there is no turning points. Number of turning points here are 0. Do you see that? No turning point at all. It just goes. And this is kind of thinking and going forward. Thinking and going forward. Never bending, right? Never turning. Now let's look into another scenario. Another scenario is, let's think about a turn this time. Now it's a 7 degree. Let's assume that leading coefficient is positive. So our assumption is here, we are assuming that a is greater than 0. That means a is positive. That means end behavior is this, right? Right side up and opposite ends. Perfect. Now, you're starting from here and you have to go there. Let's say that you have taken a turn. If you take a turn, then how will you reach there without taking another turn? So that means you have to take another turn. You see, 2 turns. You cannot just take 1 turn and reach quadrant 1. So you have to take turns in pairs. So the next possible turn for you is 2. You cannot have 1 turn. Do you see that part? Let's try one more. Okay. Let me draw with a different thing. So let's say this time we take a turn and we take another turn and then we try to do 1 turn. Now if I take a turn, I have to take another turn so that I could land up there, right? So 1, 2, that's the first 2, and 3, 4. So number of turning points here becomes 4. Correct. But never odd numbers. Do you see we are always getting the even number of turns? And last, we cannot go more than 7, right? So let's see how many turns. 1, 2, 3, 4. So 1 turn, you have to turn again. You have to turn again. Like this. 1, 2, 3, 4, 5, 6, 7. So we are on the limit. 7 linear, right, factors. 7 linear factors will give degree of 7. Perfect. We cannot have more than that. And that's the maximum number of turns. Let's count them. 1, 2, 3, 4, 5, 6. So number of turning points here are 6. So what is your answer? So the number of turning points, all possible number of turning points are 0, 2, 4, and 6. So for any odd degree function, I could write odd degree function, right? Least is 0 and the most is n minus 1. Do you see that? And all others are even numbers. Even number of turns, 2, 4, 6, like that till n minus 1. Do you get it? So odd degree function can have only even number of turning points. That is the gist of it. Thank you.